Oops, too high. Too high. There we go. So, and here we have stuff where we're telling you that we have with replacement and without replacement. So I might tell you, I might not. So, airports, baggage scale. So this is a good example of where probability can come up in economics and business and stuff like that. So when we create things, we want them to be good, right? And we don't want bad things to go out there, right? So I don't know, you can think of Apple iPhones, right? They're known for their quality material, right? That's why a lot of people choose Apple, right? So since they're known for that, they would be very stringent on this kind of application that we're talking about here, if we were to talk about this with iPhones. So, all right. So airport baggage scales are used to determine if bags are overweight, requiring additional bag fees. The New York Department of Consumer Affairs checked all 810 scales at JFK and LaGuardia airports and found 102 of them are to be defective and ordered out of use. So that gives us a proportion, a probability of randomly choosing a scale that is defective. Right? We have a probability, so if I say D equals defective scale, something like that, then the probability of choosing one defective scale would just be, I got 102 defective scales out of a total of 810. This doesn't answer any question, but it's setting up a probability, right? It's setting up a proportion, setting up a percentage for us to be able to use in terms of this system that we're talking about. With that in mind, let's talk about if I randomly choose 2 of the 810 scales are randomly selected with replacement, we want to find the probability that both scales are defective. So with replacement. Yeah, so with replacement means what kind of system do I have? I'm putting it in, I'm putting the scales back in, so I pull one out, whether it's defective or not, I'm going to put it back in into the process. So yeah, independent, that's the good case. Independent's the good case. So if that's the good case, then what am I going to do to find 2 defective scales? So this would be the probability of defective and defective. The first one's defective and the second one's defective, so that's PD. What am I going to do to that PD? Yeah, square it, multiply it by itself, square it. So to get used to that notation, we can square it. So I would literally take 102 divided by 810, and I would square that fraction. Question.
Thank you.
So I probably need some help here. What's that? Oh man, it's giving me the fraction. That is big. Yeah. Is there? So did you use GeoGebra? Yeah. So GeoGebra can give you the fraction, simplified form of the fraction. When you did that, it probably came up with a squiggly line after the squiggly hit enter. So yeah, 0.0158, like this, 57. Wait. Okay, wait. So let's just do 4 decimals, I guess. So 1.0157 or 8. 8. No, that's totally wrong. Evelyn said it right, and I'm messing it up. 0.1587. 57. So let's just round to 9 there. 5.9. There we go.
5.9.
5.9.
Just 5.9?
Yeah, 159.
Cool.
0159.
015.
No?
No, it's just like it's.
I got a fraction.
Through GeoGebra? Okay, so if you hit enter, and it'll give you a little squiggly box, squiggly equal to sign box. You want me to show it to you? You see it? So that's the cool thing about GeoGebra. It can simplify the fraction for you, right? Some fractions, it won't give you the fraction because it's just too god-awful, and even GeoGebra notices that kind of thing. So, but if you do the problem and you hit enter, it'll maybe give you the fraction, or it might give you the decimal, all right? If it gives you the fraction, it'll give you a little option, like it'll have a little blue box off to the side where it has the approximately equal to thing. And then you hit that, it'll give you the decimal, yeah.
So did you round this?
Yeah.
Yes, we rounded it. GeoGebra gives us lots of decimals, even more than our standard calculator. And we do want to get to know GeoGebra, right? Because we have standard deviation on this test. And then the next, in 4.2, you're going to see another formula. In 4.3, we're going to see another. All right. And I think we're going to make it.
What's it? Is that 0.0159?
Yes. No, that's just, I couldn't erase it for some reason. Go away. All right. So let's go through the next one. I will show one of these when we get to kind of our harder one. I'll show GeoGebra on it. So, but yeah, do get to know GeoGebra. I had my support class last night, playing around with it, kind of thing, to try and get to know it. There was a couple people that were still having problems with it. Right? You don't want to have those problems during the test. It really is just getting over that hump of the initial phase of trying to figure the system out. Because it's a little funky in there, but it's a really good program once you get over that. All right. So if 2 of the 810 scales are randomly selected without replacement, what does a without replacement mean?
Not putting them back.
So it means dependent. We're dependent. I'm pulling it out. When I pull one out, I pull it out completely. It changes my denominator, changes my numerator. So find the probability that both scales are defective. So this is P of D, first D, let me say first D and second D.
Oh boy.
So notation wise, that would be the P of the first being D, defective, times the P of second, the second being defective, given we already pulled that first defective out. That's again just the notation. I think the fractions do make more sense. We already took it.
Sometimes when this is given in the book and given all of a sudden means and I get confused.
It doesn't mean and, but there is a relationship, right? There's that formula that we talked about. So I understand, the confusion with it. And sometimes I find myself getting a little bit, is that an and statement or is that a given statement that I was talking about?
Yeah, right.
So this is an and, yes. Well, you don't think it looks like an and? It doesn't look like it. I know that. It's sarcasm.
We had 2.
All right, so what's the probability that the first is a defective scale? 102 out of 810. Now I pulled that defective scale out of the system. One of them, right? That first one I picked. I put it off to the side. How many defective scales do I now have? 101 out of 809. 101 out of 809. That's how this changes.
And we're done?
Well, I want to calculate that, so I'm going to multiply those in GeoGebra or calculator. I do believe GeoGebra is a little bit easier here. It does it better. So if we do that, I think I get 0.0157. A little bit different. A little bit.
That formula where you divide, that doesn't count. It's like this one.
You could do that and statement. It's too much work though,
Okay.
right? Just think I pulled that one out
Just leave it alone.
because that's what we're given, right? I pulled the one scale out. I have one less of those defective scales. I have one less scale overall.
If you use that formula, you run the long way around
Yeah.
the block.
It's gonna take a little while.
Okay, okay. All right, that was a lot.
Okay, good. I think it might be actually too challenging there
That's
too.
been giving me the blues.
Yeah, because this is what we're trying to calculate, and this is part of that formula for that. And I can't really use the formula too much. It would be a circular logic kind of thing. It would cause some serious confusion. All right, so the formula is going to fail you there. All right, so you see the little difference between those two, right? Even though it's basically the same question, right? One where I'm putting the scale back in, and one where I'm not. But you change it a little bit, right? And the only people that can decide if it's important enough is the people who make the scales, right? Is that business, right? They're the ones who decide if that little change in that percentage is important enough to them, right? Apple would probably come and say, hell yeah, that's too important, right? They want more stringency, more make sure that their product is not getting, defective products are not getting out to the population because that would ruin their reputation, right? So, right, so a little bit of difference, and it depends on us whether we want it or not. Let's go to the next one. So, talking about even larger population of scales. All right, we want to bump up our business. We want to be able to sell more scales to these. So, a larger population of 10,000 scales includes exactly this many defective scales. Don't ask me how they figure that out. No, they do some studies. And they figure it out for depending upon how many they got. So this means that if I pick a defective scale now, it's 1,259 out of 10,000 is my probability of getting a defective scale now. Just one defective scale. So to think about it without replacement, so without replacement meaning dependent system, right? And I'm not going to write down this thing again. Right, because I have it right there. It's the same statement. I'm going to find it, the probability of this first, all 5 scales. Now we're looking at 5 scales. Ew.
Yeah,
Ew. So I can't do it. And I can't literally write it down. So, right, probability, we're looking at the probability of defective and defective and defective and defective and defective. So, and defective. I need 5, yeah.
Okay, so just
Yeah.
do the little bounty.
Yeah. I'm just making sure we understand the notation.
It looks like you're writing dad.
Dad.
I mean, you could just use an ampersand.
That's probably better, and it would make more sense to people. But I'm not about that, Perry. All right, so it is without replacement, so we're just going to go for it. Probability of the first is 1259 out of 10,000. So that's the first scale. Second scale now, I pulled it out without replacement, so I got how many defective scales? 58. Out of? I gotcha. It's why I make you say it, not me. Oh, thank you. That will make a difference in my calculation there, big time. So 12, then so that's my second scale. My third scale will then be out of. Beautiful. The fourth scale. 9997. 5. Fifth scale then would be 5 over 999. Oh, I can't even fit it there. It's horrible. I needed more room. That is a horrible fraction. Multiplication. We don't need to work it, right? We got GeoGebra. So, deep breath. GeoGebra can do it for us. So if you got GeoGebra, maybe you want to play with it?
Yeah.
No? So, one thing you need to know about GeoGebra, we found this out last semester in my pre-stats class. A lot of times when you have stuff already there, you want to get rid of it. Okay? So previous stuff, right, you might want to get rid of. If you're working on one problem on the test and then you move to the second problem, right? It might be time to get rid of that stuff so it doesn't confuse GeoGebra. It makes these variables, for GeoGebra makes these variables set up so you can refer back to it, right? So we've been talking about making sets equal to A and stuff like that. So if you make a variable in one case, it might be referring to another variable kind of thing, so it gets confused. So watch out. All right, so I want to do this multiplication here, so we're just going to work the fraction. So 1259 divided by 10,000, 5 zeros. I'm going to scoot over to get out of the denominator.
Oh, okay.
Okay, and then I need another fraction. GeoGebra assumes multiplication if there's no symbol in between there, right, as we do in mathematics. So I can just do the next number. So 1258 divided by 999.
You just get out of the fraction.
Go over the side. Do the next one.